Hey guys, let's talk about some particular forces. We started going over this last week. Weight. So let's discuss that a little bit. Let's bring up some vocabulary. Mass is a measure of actual matter. And we usually measure that in something called kilograms. Oops, let's see if I can erase that. Oh, that didn't work. That worked. Something called kilograms. Okay, and force is a push or a pull on something. And we're going to measure that in something called newtons. Weight is a push or a pull, actually a pull, that results from the phenomenon known as gravity. Here's our units of force, which weight is a particular example. The Newton, if we're going to abbreviate that, we use capital N because it was somebody's name. And the more common unit of force is the pound in the English system, which not even the English use anymore. So we'll mostly be using newtons. Isaac Newton was the first person to explain why objects move the way they do. He based his laws of motion on two key concepts: mass, or the amount of matter in something, and force, the push or the pull on that mass. There's also a third thing, acceleration. Or the change in motion. So acceleration tells us about the change in the motion because an unbalanced external force has been applied to a mass. So these are actually the three major players. The law of inertia tells us about them. Objects at rest tend to stay at rest. Objects in motion tend to stay in motion at a constant speed and in a straight line unless disturbed by an external unbalanced force. The mass is the amount of matter. The force is the push or the pull. And the acceleration is a description of how the motion changes. Oops. What is mass? Decide as a group how to define mass, or if you're watching this at home, think about it for a minute and use your definition to argue if air has mass. Think about last time you were traveling down the parkway and you stuck your arm out of the window of the moving car. What happened? Was your arm pushed back, and what actually pushed it back? All matter has mass and takes up space. A solid rock has mass, so do gases and liquids. With your hand out the window of a moving car, you feel the mass of the air pushing against you as the air molecules actually bounce off your hand, and your hand is pushed back in reaction. So yes, air has mass. Measuring mass, the SI, or System International unit for mass, is the kilogram. The object to the right has a mass of 2 kilograms, as you can kind of see right here. What is force? The concept of force. A force is a push or a pull. A fairly simple idea. Usually the simpler the idea is, the harder it is to define it or talk about it. But we'll let suffice the idea of a push or a pull to be a force. Forces can cause an object to change its motion. Remember, change in motion also has the name acceleration. Can you think of some forces? We've talked about one already called weight. Can you think of any others? Examples of forces: weight, which we already talked about. Friction, when two surfaces slide past each other and their surface features interact. Usually the product of friction is heat. And when two things slide against each other, like say, I don't know, you slide a book across the floor, eventually it comes to a stop. What's happened to its energy of motion, or kinetic energy, is that through friction, it's changed to heat. And so the kinetic energy disappears as it changes to heat, and the book slides to a stop. Tension in a rope, force from a spring, and either tension if you stretch the spring or compression if you compress it. Electric force is when you connect a battery to a light bulb. The electric force, or electromotive force, is what causes the charge carriers to flow through the light bulb and to get the light bulb to glow. Units of force. Force is measured in newtons, abbreviated uppercase N, uppercase because it was somebody's name, Newton. A definition of a newton is the force required to change the velocity of 1 kilogram of a 1 kilogram object by 1 meter per second in 1 second. So a newton is 1 kilogram meter per second squared. These would be equivalent units: the kilogram meter per second squared and the newton. Weight is a force. Weight is the force of gravity acting on objects with mass. How is weight different from mass? Well, let's think about this. How is weight different from